definition of the pH scale. And normally I say you can use the natural logarithm, the ln, or the log to the base 10, log, interchangeably. But when you're talking about pH, you specifically have to use logs to the base 10. You can't use your natural logarithm button on your calculator. This is the definition. And you may have heard in the past, the pH scale goes from 0. Hopefully you've heard this. 14. 7 is
neutral.
Neutral. 14 is
Basic.
Basic. Acid. And then you can do some easy calculations. For instance, I won't do easy ones first. I want to just look at molar HCl. You know HCl is a strong acid, so it dissociates completely. And you say the H plus is 12 molar. What do you get for the pH of that solution? And everybody says, well, I got my calculator. I'll just do that quickly. I need to turn it off here. There's my button. And I get minus 1.08. What's wrong with that?
It's a negative number.
So that can't be. And by the way, when you look up the log of 12, it says 1.08, but you always have to put the minus signs in because your calculator doesn't remember that. Unless you have a chemical calculator that you say put in 12 and you push the pH button and it'll say minus 1.08. But the reason this happened is because the definition isn't quite right. It's the log of the activity of the hydrogen ion concentrate, the log of the activity of the hydrogen ion. I got one too many words in there. So the maximum value you can have for activity is 1. Remember, that's the rationale I used when I was talking about why we didn't include solids or liquids in the equilibrium expression. Because when we're thinking about it in terms of activities, if we were putting that in, and it was a solid or a liquid, we'd have 1 squared and it wouldn't affect the answer at all. So we just don't bother putting solids and liquids into the equilibrium expression. And the same thing is happening here. So when we start talking about some of these concentrations, what it means is the activity of the hydrogen ion is going towards 1. And since that's about as concentrated as you can make an HCl solution, we'd say the activity of that was 1, and then we'd have a pH of 0. Okay? So we're not going to worry about that. We just are not equipped to handle activities. But notice, as soon as you get to like 0.1 molar, the negative log of this, since the log is the exponent of 10, the negative log of this would be what? 1. And at 0.1 molar, the activity is pretty close to a 1, negative 1, a 1, sorry, minus sign comes in here. So there, it's getting very close to 1 already. When you get down to the activity number and the concentration number, this is the concentration of the hydrogen. The activity number and the concentration number are now almost exactly the same thing, unless you're looking at about the So it's starting to work better, pH 2. Go. What's the pH for this? Exponent is -8. What would you say the pH was? 8, somebody said. But pH 8 is basic, and I've got an acid. What happened? So you know it can't be 8 because that says it's basic. So it means you're doing the problem wrong. This problem used to be in about the 6th and 7th edition of this textbook. Then they dropped it off for a couple of semesters and all the instructors complained because it's really a good problem. And what it shows is that you're not thinking about everything else. And what you're not thinking about is HCl gives you hydrogen ion and chloride ions. Water gives you what?
Hydrogen ions and oxygen ions.
Hydrogen ions and hydroxide ions. And so when you get down to this low concentration, you have to take both sources of hydrogen ion into consideration. So I'll let you think about that problem until the next time, and I'm going to move on.